Hello everyone, I am Indrajyoti Gaine. Presently, I am pursuing my PhD from Department of Mathematics and Statistics, IIT Kanpur. I am a PMRF fellow right now, and before that, I was a CSR fellow. I have cleared my CSR net with 108 rank. Okay, so in the previous lectures, we were discussing about permutation, and in the last lecture, we mentioned what is combination. So combination is nothing but permutation where repetition is not allowed, or you can say that the order is not that much matters in this case. So here we have discussed how we can define combination. So by the example, we understood that a straight line joining 1 and 5, or a straight line joining 1 and 2, or 2 and 1, these two are not two distinct elements. In case of permutation, we consider these two cases as distinct elements, but in case of combination, we don't consider these two cases as a distinct element. For example, in a real life, you can consider that two apples are not indistinguishable because both are apple. Their order is not that much important. You eat a small apple first and the large apple first. It doesn't matter that much. But in case of numbering like 1, 2 or 2, 1, these two are completely different two numbers. But in case of this straight line, you can see that the joining line from 1 to 2 or the joining line from 2 to 1, both are same. So in that case, we will consider that two element as one. And by that, we don't allow, by that, we are not allowing that many extra cases. For that, we are dividing by that number and we obtain the exact number of combination. And from there, we have found the formula for combination. So how we can count the combination? So here was the formula. Here was the formula. And we can manipulate that by this thing also. Okay. After that, we have discussed that what is the value of NC0 and NC1. In the previous lecture, we have discussed about the value of NPN and NP0. So these are all required for some special purpose, because in some cases you will come up with something which you need to come up with. You need some combination of zero. I mean, you have to choose a zero element from n elements, and this case can come up. So for that purpose, you need to be aware of NCN, NPN, NC0, and NP0. All these cases. After that, we have learned one formula, that NCR plus NCR minus 1, this is equals to N plus 1 CR. And we have proved that statement. Now, in today's lecture, we will continue this the discussion of combination, and we will see some example of both permutation and combination. So let us start with today's lecture. Okay. So let us start with the this formula. So NC N minus R. Okay. So we know the formula for NPR. What is that? NPR is nothing but N factorial divided by N minus R factorial. Fine. What about NCR? This is equals to N factorial divided by N minus R factorial divided by R factorial. Because we are allowing the R factorial ordering, we are not considering the orders of these R factorial elements or R many elements as a distinct objects. So that's why you are dividing by R factorial. Now, what about this NC N minus R? So by formula, if we consider this N minus R as P, then this is nothing but okay, you can write in different color so that you can understand properly. NCP. Fine. So by formula, this will be like N factorial divided by P factorial into N minus P factorial. Fine. So let us put P equals to N minus R in this. So what we will get? We get N factorial divided by N minus R factorial n minus r factorial. Fine. And this implies n factorial divided by n minus r factorial into r factorial. Fine. Now, from here, you can clearly see that this is the formula for NCR. Fine. Therefore, we can use this equality in case of some convenient cases. Like in some case, we need to be convenient to write this one term in term of another term, so that we can calculate the whole problem in easy manner. So for that purpose, you should recall this case. But is it the case for permutation? Let us check. So in case of permutation, if I find n p n minus r, then this will give us n factorial divided by n minus r factorial. Fine. So this will give us n factorial divided by r factorial. And what about npr factorial? Npr is n factorial divided by n minus r factorial. So clearly these two terms are not equal, this and this. So we can write that np n minus r, this is not equal to npr. So in case of permutation, these two terms are not equal, but in case of combination, we should recall that these two terms are equal. This is just because this formula of this combination. Okay. Now start one example, or to understand to solve how can we solve these things. So let us do one example. Okay. If NC9, this is equals to NC8, then find NC70. Okay. Now if I can use this formula or not, let us check. So we will use this formula to get the answer. So we can go with both the way. One case we can just use the formal definition of combination, and we can find the n. So in the first case, let us say case one. Case one is, let us use the formal definition of combination. So we get NC9, this is equals to NC8. So this thing gives us n factorial divided by 9 factorial into n minus 9 factorial. And this time gives us n factorial divided by 8 factorial minus n minus 8 factorial. Fine. Now, if I do the calculations, what I get, we will get n minus 8 factorial divided by n minus 9 factorial. This is equal to n factorial divided by 8 factorial. Sorry, 9 factorial divided by 8 factorial. Now this thing gives us n minus 8 into n minus 9 factorial, which is divided by n minus 9 factorial. Why I will get this? Because we know the formula about the factorial, that n factorial equals to n into n minus 1 factorial. So obviously, if I put n minus 9 in place of n, in place of n, if I put n minus 8 factorial, you obviously get n minus 8 into n minus 9 factorial. Sorry for this lack of space. n minus 8 factorial equals to n minus 8 into minus 9 factorial. Fine. So now we can eliminate these terms. And ultimately we get n minus 8 equals to 9, which will give us n equals to 7. So by this process, we can find n equals to 17. Okay, by this process, we can find n equals to 17. And from here, if I put the value of n equals to 17 in the required answer, we will get NC17. Now put n equals to 17, what we will get? 17C17. Now if we calculate this, we'll get 70 factorial divided by 17 factorial into 17 minus 17 factorial, which is equals to 1. Now, in this case, clearly if someone know this formula, like this one, what, okay, NC0 and NCN formulas like this, like, okay, these formulas, NC0 and NCN formulas, then he can easily, just one step, he can just by observing this term or by this term, he can write this term. He don't need to calculate all these things. But if you don't know, you can calculate or you can get some calculation to obtain this answer. But in case of competitive exam, you should be very much careful about time. So you need to recall all these facts so that you can easily write the answer properly at just minimum second. Okay. So by this process, one can do the problem, and he have to do this lot of calculation, and we have to find the value of n. But if I use this thing, can I solve this problem by just one or two lines? So let us check that. So case 2. Given that NC9 is equal to NC8, and we know that NCR, this is equal to NCN minus R. This thing holds, we know, and this is given. So obviously one of these 9 and 8 should be equals to R. So let R equals to 8. Then obviously n minus R should be 9, which implies n equals to 9 plus R, which is equals to 9 plus 8, which is equals to 17. And then find the value 17C17, which is equals to 1. So in this case, you can clearly see the least number of steps you need to get this answer. Here you need to calculate all the terms and explicitly, and you have to find the value of n after a long steps. And you can do some calculation mistake if you forgot the formula for factorial. But just if you use the formula for this thing, in just one step you can get the answer. Fine. Okay. Let us do another example of same kind. If NC8, this is equal to NC2, then find NC2. Similar problem. What I will do, just observe here. We know that NCR, this is equal to NC in minus R. So put or let assume R equals to 8. One can take R equals to 2 and you will get the same answer. This implies n equals to 2 plus R, which is equals to, you can say, 10. So obviously n equals to 10. So this implies 10C2, which is equal to 10 factorial divided by 2 factorial into 8 factorial, because 10 minus 2 is equal to 8. So this will give us 10 into 9 divided by 2 is 45. In just few lines, we get the answer. Okay. Now, let's discuss another question. Let us assume that 2NC3 NC3, this is equal to 12:1. Okay. Now you have to calculate the value of n. What value of n should satisfy this condition? So you need to determine the value of n for which this condition is satisfied. So for that, use the formula. Nothing else will work. Or if it works, then you can find out that, and it will be a good observation. So what will be the 2n factorial 3 factorial divided by 2n minus 3 factorial divided by n factorial 3 factorial n minus 3 factorial, which is equals to 12 divided by 1. Okay. Can I use any further formula here? Okay, fine. So from here, what I will get? We get 2n factorial 3 factorial 2n minus 3 factorial 3 factorial n minus 3 factorial divided by n factorial. Okay. Now this 3 factorial will go equals to 12 into 1. Now how you can manage all these terms? So here you have 2n factorial divided by 2n minus 3 factorial. Here you have n minus 3 factorial. This is n factorial. So how can I write this? 2n into 2n minus 1 into 2n minus 2 and so on up to which time it will come? 2n minus 3 2n minus 3 sorry 2n factorial, right? So 2n minus n up to 2n minus n factorial. 2n minus n, so 2n minus n plus 1 factorial. Sorry. N plus or minus 1. It is n plus 1 up to up to n plus 1 it will work. And there it will be like 2n minus 3, 2n minus 4 and so on, and it will work up to 2n minus n 2n n factorial, right? N factorial means 2n minus 3 minus n. So same term will work up to this. So we get up to this thing. Now you can see that after this thing, from upper part and from lower part, you can compare. If you compare, then you will see only these many terms will left. 2n minus 1, 2n minus 2, and this is equal to 12. Now one can solve this equation and he can get the answer, proper answer for n. Okay, so by this process one can find the value of n, and you need to be aware of this n is a positive integer, or so that this should be a positive value. So just calculate this equation and you will get some positive value. That will be the value of particular n. Okay. Now let us do another example. To understand the permutation and combination properly, you need to go through the lot of examples so that you can understand the things properly. So the example is question. Find the number of arrangements of the letters of the word in the independence. Find the number of arrangements of the letters of the word independence. And after that, in how many words? In how many of these arrangements do the word starts with P, do the words begin with I and end with P. Okay. So the question is that find the number of arrangements of the letter of the word independence, and in how many of these arrangements do the word starts with P, and do the words begin with I, end with P. Okay. So at first we need to find all possible arrangements of the word independence. So in that case, one should notice that in the word independence, INDEPEN. Sorry, I have not written the N word. It will be there. Independence. Okay. Now in this word, you can see E comes 1, 2, 3, 4. 4 times. N comes 1, 2, 3. 3 times. And what comes twice? D. D comes 2 times. Fine. And how many words will it have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here are 12 letters. And we need to find all possible arrangements of this word, keeping in mind that E, D, and N are repeated. N repeated 3 times, E repeated 4 times, and D repeated 2 times. Fine. Now, the number of arrangements for 12 letters we get the number of total possible arrangements are. I will use the permutation formula for permutation, and where the repetition is will be considered. That is, repetition will not be considered, where the word one or two letter can be repeated twice and thrice. So we have used the formula like what? n factorial divided by, the formula was, what was the formula? N factorial divided by Pn factorial, P2 factorial, and Pk factorial, like that. Now, here, total number is 12 factorial. How many of them have been repeated? Repeated numbers are 3 factorial, 4 factorial, and 2 factorial. Because here 3 words have been repeated, and one repeated 3 times, another repeated 4 times, and another repeated 2 times. So by that, we can say that this is the total number of possible arrangements. Okay, now one can calculate the value of this. It will be a large number. So I will not calculate this thing, but yes, this is the exact number of total arrangements. Fine. Now come to the first case. Here in the word, there are 12 letters, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in this case, P is fixed in the first position. So here we are left with 11 more positions. 11 positions are left. And how many words we have? 11 many words. Among them, how many are getting repeated? This is a question. Now, here you can see we have put the value, put P in the first position, and P is not a repeated term. Okay. So, in 11 many left words, we need to be repeat. We have the repeated words again. So, in the left positions, like 11 positions, E is present, T is present, and N is also present. Okay. So, the repeated element will appear in this 11 position. Fine. So, how we can count the all possible numbers? So, the number will be like 11 factorial. Among them, D will present, which is repeating 2 times. So 2 factorial. E is present, that is also repeating 4 times. So 4 factorial. And N is also present, that is also repeating 3 times. So 3 factorial. But if in case I told that the word starts with D, or suppose the word starts with E, in that case we have fixed one repeated element, so we have to count only repetition of the rest of the many elements. Okay, like in case of, if I fix the first element as E, then we are left with only 3 elements of 3E which can get repeated. Okay, but in case of this case, where P is the fixed element for the word, in that case the rest 11 many elements, among them 4 E are present, so they can be repeated, and 4 2D are present, and 3 N are present. So in that case, there will be no change in denominator part. I hope this is clear. Now in the second example, we need to find an word which has 12 letters, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, which starts with I and ends with P. Okay, so we are left with 10 positions, and also we are left with 10 words. Okay, so here I and P are fixed, right? I fixed and P fixed. So again, you can see that all the 4 P, all the 3 N, and all the 2 E can be appear in this 10 position. So as we have mentioned in the previous case, Here also the total number of wards will be will be 10 factorial divided by 2 factorial, 4 factorial, 3 factorial. Okay. In that case also, if I fix the sum of the repeated element in the first position or in the last position, then also we can reduce the number of denominators. I can say that denominator can be changed. For example, if I put some word with the first element as E and last element as E, both the elements are E. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So for first position will be E and last position will be E. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are left with 10 positions. So all possible words will be 10 factorial divided by here some change will be there. So E repeated 4 times, but 2 of them are fixed. So we are left with only 2 is. So for E, 2 factorial. For E, we will write 2 factorial. For N, we will write 3 factorial. And for E, no, sorry, for D, we will write again 2 factorial. Okay. So here you can see the clear-cut difference between the previous case and the next case, where I have fixed 2 repeated element at the beginning and the end of the word. So this kind of scenario one can see if they fixed some repeated element in case of words with repeated elements. Okay, now go to the next example. The question is, committee of 3% is to be constituted from a group of 2 men and 3 women. In how many ways can this be done? And the second part is, how many of these committees would consist? Would consist 1 man and 2 women. Okay. So what is the question? A committee of 3% is to be constituted from a group of 2 men and 3 women. In how many ways can this be done? So the first part, for the first part, you just recall that here we have 5%. Among them, you need to pick any 3% and make a committee. It is independent of the choice of men, women, anything. You can choose the 3 women and make a committee. Or you can choose 2 women, 1 man. Or you can choose 2 women, 2 men, 1 woman. It is up to you, whatever you can do. Okay. So in that case, but observe one thing, that among the 2%, it will not that much matter if you choose the first person first or the second person first. For example, if I tell that one person is tall and another person is short, so if you choose the short person first or if you choose the long person first, that will not matter in this case because both are person. So you don't need to be bothered about height of the person. That will not be that much matter. So I am giving this example to say that here the elements are not distinct. Like ordering will not be important. So just remember that in these cases you need to be go with combination rather permutation. Okay. For permutation, they will consider like the two person as two distinct elements and they will take care of the order. But in case of combination, they will not take care of the order. They only choose two men they will choose a person among a men among two men. Fine. So in case of the first part, we have total 2 plus 3 equals to 5%. You have to choose 3%. So how many ways are there to choose 3% among 5%? So number of possible committees will be 5C3, which will give us 5 factorial divided by 3 factorial into 5 minus 3 factorial. Okay. And this will give us the number 4 into 3 factorial divided by 3 factorial into 2 factorial. Fine. This will give us 5 into 4 divided by 2, that is equals to 10. So only 10 committee can be formed by choosing 3% among 5%. Fine. Now come to the second part. How many of these committees would consist one man and two women? Now they have specified that in this committee you have to give one man and you have to give two women. Now let us start as like this. You have to choose first one woman, then you have to choose another woman, and you have to choose another man. So let us consume that first choose two women, two steps. Second part, step 1. Choose woman first. Step 2. Then choose one man. Okay. Now choose two women first. So you have three women. Among them, how many possible ways are there to choose two women among three? So this thing will give us the number 3C2. So this many ways I can choose two women among three women. Correct? Because the order will not be that much important in case of this example. Now for each choice of this choice, like for each choice, we can choose one man from the two men. Correct? So how many ways I can choose one man from two men? 2C1. Now just observe the relation. What relation? That For each preferred choice of 2 women, you can get this many choices of men. Okay. So therefore, for one case, we get this many. For this many case, how much we will get? We will get 3C2 into 3C1. Fine. Let us write it properly. 3C2 multiplied with 3C1. So this is the number of total committees we can form by choosing 2 men, 2 women, and 1 man. Fine. What will be the number? Number will be 3 factorial divided by 2 factorial into 1 factorial into 3 factorial divided by 1 factorial into 2 factorial. So, okay, sorry, no, it's not 3C1, it will be 2C1. 2C1 1 factorial, 2 factorial. So this will give us 3 into 2, which equals to 6. So we can overall we can make 10 committees. Among them, 6 committees contain 1 man, 2 women. And how we can find that number? This is the way. Okay, let us do another example. Okay, let us do the example, this one. Okay, which one we can do first? Okay, question is, in how many ways can 5 girls and 3 boys be seated in a row so that no 2 boys are together? Okay, so in how many ways can 5 girls and 3 boys can be seated in a row so that no 2 boys are together? Now, how we can interpret this question? So, no 2 boys are together. This means that after each boy or in between 2 boys, there should be 1 girl, right? At least 1 girl. There can be 2 or more girls, but there should be at least 1 girl, correct? And anyhow, there cannot be like 2 boys together. It can be two boys together. Like if blue are denoted by boys, then there should be at least like this, or it can happen like this. This is the case 1. This is case 2. All possible kind of thing can happen. Like at least 2 boys will be separated. Fine. So to solve this problem, how we can go? So first choose the 5 many girls. So they can sit like this. So girls are denoted by red one. So 1, 2, 3, 4, 5. Now to satisfy the second question or second property, that the 2 boys be seated in a row so that no 2 boys are together, that is possible that when these 3 boys can sit in these places, correct? Now it may happen that the boys are sitting like this. One is here, two is here, three is here. Or it may happen that one is here, two is here, three is here. Okay? So it all possible combination can be happen. Now, before going to the vacant places, we can arrange the 5 girls first. Now, how can we arrange the 5 girls? So the case is that we have 5 many elements and we have to place them in 5 position. So this will be nothing but 5 factorial, or you can say 5 factorial ways are there to seat the girls. Seat the girls first. Fine. Now for each choice, for each of this choice, each of the way, we can arrange boys in some in whatever I have told in that way. Like maybe this is a choice of arranging the 5 girls, and there are vacancies like 1, 2, 3, 4, 5, 6. So there are 6 vacant places. Among them, the boys can sit. So how many ways a boy can sit? So 3 boys can sit 6 3 way. Why 63 way? Because you have the boys have 6 choices. Among them, they can sit. Fine. Now, 3 many boys, how they can sit there without by not that much aware of the ordering? Then that will be 6C3. That is, who is sitting in the first position first, that will not be matter, but position will matter. Okay. So the 3 boys can sit by 6 places in 6C3 ways. Okay. Now these girls can sit in 5 factorial ways, and for each way there are this many ways of hitting boys. Is it clear? The girls can sit in 5 factorial ways in this row, like these orange places. Fine. And for each possible way of the sitting of these girls, the boys will sit among these 6 places, and that will be the way, this many ways. So the total number, of ways will be 5 factorial into 6C3, which will give us okay. You can calculate the number. I will not calculate right now. Yeah. So this many ways we can have. Okay. Okay. Now go with the last example for today's class. Example is a group consists of 4 girls and 7 boys. In how many ways can a team of can a team of 5 members be selected if the team has no girl in first case, 2, at least one boy and one girl, 1 girl, and third case is at least 3 girls. Okay. The question is that a group consists of 4 girls and 7 boys. In how many ways can a team of 5 members be selected in the team which has no girl in the first case, second case at least 1 boy and 1 girl, and in the third case at least 3 girls? So total number of members, how many are there? Total member is total member is 7 plus 4. That will be 11. Fine. Now you have to choose 5 many members among them. And now if they didn't put this condition, you can clearly choose 5 many members and that will be 11C5. So there is no that much need to worry about. But in case of this example, they have put a first case that no girl. The number of girls is 0. So you have no access to the 4 girls. So you can only choose 5 many members among 7 boys. Okay. So in the first case, you will get the number like 7C5. Why 7C5? Because there are no girls, means you can't pick any member from these 4 girls. So you are only left with, even though there are total 11 members, you are left with only 7 boys. Because they have put the condition like there will be no girls in the committee, or you can in the group. Okay. So these are the number of teams can be made. The number of teams which can with no girls. Fine. Now come to the second case. They are saying that at least 1 boy and 1 girl. Fine. So there are 5 many members can be in this team. Now there are some sub cases. How? So at least 1 boy and 1 girl. So one case can have that 1 boy, 4 girl. Second case can be 2 boy, 3 girl. Third case can be 3 boy, 2 girl. Fourth case can be 4 boy, 1 girl. Fifth case can be 5 boy, 0 girl. But here they have put the condition that at least 1 girl should be there. So this case will not be there. We will remove this case. So only 4 possible cases can be obtained. Now for the first case, how many possible teams we can form? So in this case, we can form 1 boy. So how many choice we have? 7 boys. Among them, we need to pick one boy, so 7C1. Now, choice of depending upon this choice of this first boy, that is one boy, we have this many choices of girls. Sorry. 4C4. We have this many choices of girls. Fine. Second case, we have this many choices of boys, and for each choice, we have this many choices for girls. For third case, we have this many choices for boys, and for each choice, we have this many choices for girls. And for the fourth case, we have this many choices for boys, and for each case, we have this many choices for girls. 4C1. Okay. Now, by this condition, we have put in that at least one boy and one girl. So we have obtained that 4 different cases, and we have calculated the number of possible teams for 4 different cases explicitly. Now you need to add all these terms to obtain the case that at least one boy and one girl. So what will be the answer? So the total number will be of team with at least one boy and one will be 7C1 into 4C4, 7C2 into 4C3, 7C3 into 4C2 plus 7C4 into 4C1. Fine. So you can calculate this total number and you can obtain the exact value of total number of teams with at least one boy and one girl. Now come to the third case. Here also I will explain the concept and you can do yourself. So at least 3 girl. So at least 3 girl means here you can get only 2 cases. One is 3 girl, 1 boy. Another is 4 girl. Sorry, 3 girl, 2 boy, 4 girl, 1 boy. So the total number of team will be number of team will be as we have discussed before, 7C2 into 4C3 plus 7C1 into 4C4. So this is the number. And you can why this number will be, you can clearly understand from the sub case before sub case. Okay, why this is? Because in this case number will be 4C3 into 7C2. In this case, this will be 4C4 into 7C1. So we just added those 2 terms. Okay. Okay. So thus you can understand how and where you need to use the permutation and where and how you need to use the combination and how you can get the result of the required question. In the next class, we will discuss some more examples so that this concept gets much more clear. So here we will stop today's lecture.